Hi everyone, welcome back to my channel. So if you are new to my channel, consider subscribing my channel. And today we are going to discuss about lexical tokens. So what are these lexical tokens and why are they important? Why are they important in Verilog? Okay, so basically lexical tokens are nothing but they we call them as syntax. So whenever you are writing some language or whenever you are learning some language is nothing but building a program by using some rules and regulations, is it or not? Like every language is will be having its rules and regulations, and by in with respect to those rules and regulations we will be building our program, is it or not? So basically, by using the lexical tokens with respect to some rules and regulations, we will be building our Verilog program. Okay, and in this Verilog HDR you are having some lexical tokens which are similar to C language. That is why I already told you in the starting classes, in the before classes, that Verilog is very similar to C language. So that is why some of the syntaxes are similar in C as well as in Verilog. Okay, but some differ. Okay, so let us see what are the things that are similar to C language and what are the things that are differ from C language. Okay, so basically in Verilog HDR, these are the basic lexical tokens you will be learning. Okay, the first one is white space. So white space is nothing but the space that is left. Okay, generally it's a space bar between the programs. See, if you see in this program here in the module, see, if you see, after module you have left some white space. In the same way, after input, after output. So basically, when you left this white space, generally Verilog doesn't consider this as an error. That means Verilog simulator, whatever simulator that you are using in the Verilog, that will ignore this particular space, and that which is why, because in Verilog it is already inbuilt that the white space can be ignored whenever you are leaving any white space. Okay, that means whenever you are leaving any space between the things, it will be ignoring that and it will be simulating the remaining program. Okay, so basically this is what the white space is. See, white space can contain characters for spaces, tabs, new lines, feeds, etc. That means you can leave the white space between anything, like hash b, it denotes blank space. Okay, hash t, that means tab space. Hash and nothing but when you when you want to enter into the new line. Okay, so this is about white space. So basically, this white space is ignored in Verilog in all cases except in case of strings, and when you are separating the tokens, that means lexical tokens, whenever you're separating them, it doesn't ignore that two cases. In the remaining all the cases, it will be ignoring the white space. Okay, and now comments. Okay, comments is nothing but, for example, whenever you want to increase the readability of your code. So in the in the before classes I have told you, whenever you're writing the code is not your code. That means everyone should understand particular code what you have written. Okay, so how will you do that? How will you put your ideas in that code? Is it or not? Code means it should contain, as I already told you, it will be having some keywords, it will be having some logic and all. So in between these keywords and logic and all, how you will convey your thought, like why did you put that particular logic there, how are you going to convey that thing? So for that thing, when you want to convey anything, you can convey it by using the comments. Okay, comments is nothing but, generally you will be having again two types of comments, like single line comment and multi-line comments. So basically, when you are using a single line comment, that means when you want to write anything in a single line, then you can use just two hash things in order to write this. See, like this is a single line syntax. Okay, that means whenever you want to write anything that doesn't belong to your code, that means that doesn't belong to the thing, but you want to convey something in your code. So in those times, what you will do means you will be using some two hash slash lines, and whenever you use two slash lines, it is considered as a comment, and the Verilog will be ignoring that and it doesn't simulate that particular thing. Okay, so this is about comments. Okay, and again you are having single line comment as well as multi line comment. In single line comment you will just use two slash symbols. Okay, and whereas in multi line comments you will be doing that with in this way, like slash, star, and then star and slash. Okay, so this is about single line and multi-line comments. That means whenever you want to write something, you will be writing within this hash and star, and then after ending the comment, whenever you want one, like you have written some 5 to 6 lines, and then you want to end the comment. So for that, first star and then hash. Okay, first time is first slash and star, and then star and slash. Okay, so this is about comments. And then coming to operators. So what are these operators? Basically, if you see in this code, okay, so this is our just syntax like module, and you have declared some inputs, outputs, everything. Now coming to logic here, if you see the logic here, what is the logic? Assign sum equal to a xor b xor c in, and assign carry equal to a and b, or b and c in, or c in and a. So if you see here, this XOR symbol, this AND symbol, this OR symbol, so all this belong to the operator section. Okay, so basically these are called as operators, and by using these operators only you will be writing your logic. Okay, in Verilog you are having three types of operators. First one is unary, binary, and ternary. So based on the number of operators you are using, for example, you are using only single operator here. See, for example, C equal to XOR of 40 B 1100. So you are using only single operator here. So since with only single operand, okay, you are using only single operator with a single operand. So since you are using only single operand like C, okay, so that is why this is a unary operator. And when you are using two operators like operands, like if you see here, C equal to A into B, that means is into B, that means you are using two operands. Okay, so that is why this is binary, C equal to A and B. That means you are using two operands. Since you are using two operands, so this is a binary operator, that means two operators. Ternary means if you see here, you are having three operands. SCL is one operand, I1 is second operand, I0 is third operand. So here if you are using three operands and two operators, see, question mark is one operator, semicolon is one operator. So in this way, if you are using number of operators like two number of operators with three number of operands, then it is a ternary operator. Okay, so basically three types of operators, and you will be using these three ways. So generally the operators are categorized into three parts, like binary, unary, like unary, binary, and ternary. And we will be using these operators in various ways, like again this operators is categorized depending upon our usage. For example, if you want to do some additions and subtractions, they come under arithmetic operations. And if you want to perform some relational like greater than or less than or shifting, if you want to perform some shifting, they come under shift operators. If you want to perform some logical operations, then they come under logical operators. So in this way, operators are again subcategorized into these number of ways, like arithmetic, relational, equality, logical, bitwise, reduction, shift, conditional, concatenation, and replications. Okay, so these are the type of operators. So now basically every operator will be having some symbols like plus minus. For when it comes to arithmetic, plus minus, into and all. When it comes to bitwise operators, it is and or XOR, like this. Okay, so basically this is about operators, like say one of the lexical token which is operator, and also you will be learning in detail about these operators in the upcoming videos. Okay, and then coming to constants. So what are constants? Basically, again, constants means you can have like integer constants and real constants, is it or not? So constant is nothing but, it's nothing but number representing some value. For example, if you say, let us say input a, you have taken some input a and you want to assign some value in it, like some a equal to 4. Okay, now I can't directly assign a equal to 4 in case of Verilog. That is what I told you. Rules and regulations is having some syntaxes. By using those syntaxes only, you can assign a value to that particular variable. Okay, so in Verilog, you are having again integer constants and real constants. So what is the syntax when you want to assign some constant to the variable? How are you going to assign it? How are you going to write the constant? How are you going to represent the constant? Okay, the syntax for that is size, okay, with tick symbol, radix, value. Okay, so this is how basically you will be representing the constant. So when this comes here, see, first is size. So what is size mean? Size mean, for example, in which like what is the length of the bits you want to transfer. For example, if you see here, I'll be giving you some example for that. Let us see the example here. See, 4 tick b 1011. If you see here, what is the size of this particular constant? The size will be 4. Okay, so you can call it as a 4-bit number. Okay, why is it 4-bit? Because you have taken here size as 4. And then b, what does this b mean? B is radix or base. Okay, base means generally you will be having like four types of in digital electronics. I think you have learned, you are having like four number systems like decimal, binary, hexadecimal and octal. So generally in Verilog, when you want to represent a constant, you can represent in any of these four ways. Okay, so these four ways will be coming under radix or base, whatever it is. Okay, so this is about radix or base. And then value. Value means whatever value that you want to assign. For example, if you see here, this is my value, so I want to assign my a as 1011. Okay, so I can't directly assign it as 1011. Okay, firstly I should tell what is this, what is the radix of this number. That means in which format it is. It is in either, I want to store it in either binary way or in decimal or in hexadecimal or in octal. I need to first represent it. Okay, and then what is the size of it? That means here if you see, this is a 4-bit size, so I will be taking, if this is of not 4-bit size, I'm taking it as a 4. Okay, then it will throw you error. That means, for example, what I'm saying is, for example, I am taking a equal to like some 2 tick b 1010. So now the compiler will throw you error. Why? Because since you are taking the size as 2, but you are taking the value which is of 4-bit wide. Okay, the size is 2 and the bit is 4-bit wide. So how can it fit in? Is it or not? So that is why it will throw you error. So the size should always be greater than the value that you are taking. Got my point? So this is how basically the syntax of this integer constants will be. It will be size, tick, okay, radix and value. That means, for example, if you want to assign some value, then it should be in this way, like 4 tick d, okay, like some 256. Now what is this? This 256 is the value, this d is the radix and this 4 is the size. Okay, so in this way you will be representing when you want to assign a number or when you want to assign a constant to the particular variable, you should do this in this manner. Okay, and then Coming to, whenever, for example, if you see here, this is let us see this example. Okay, so this is such a big number. This is of like 16-bit decimal number. Okay, now I want to assign, I want to okay, this is the decimal way of representing it. Now if I want to represent the same in either binary or in octal or anything, then what can I do? If this is in such a way, then it is as soon as you see it, you can't recognize the number, like how much is the number and all. So in order to increase the readability of this, you can generally use the underscore symbols between four, so that now if you see this thing and this thing, now this is easy to read, is it or not? So that is why basically you will be using underscore. Even though you are using underscore based on the lexical tokens, this underscore will be ignored. That means whenever you are using underscore in between the values, or in between the names, in between the identifiers, anything, when you are using an underscore in between anything, the Verilog will be ignoring that. That means the simulator will be ignoring that. It doesn't consider as a error. Okay, so this is about constants. Again, when it comes to constants, if you see here, as I already told you, the size is important. That means the size should always be mentioned. What if you doesn't mention the size? Okay, even though you doesn't mention the size, basically everything is it will be having some default size, is it or not? So whenever you doesn't mention any size, so based on the default size, the values will be assigned to that particular default size. Say, let us consider a sized constant has a size specifier present. That means here if you see, this is the sized constant. How can you say whether it is size constant or not? That means whenever you are having the size before base or radix, then that means this is the size constant. If for example, if you see the example here, it is just like this. So that means the size is not present here. So in this way, if the size is not present, then what happens? Here this is the unsized constant. So if there is an unsized constant, basically in this type of thing, what happens means this unsized constant is considered as a default size. That means since you didn't mention any size, so it will be taking the default size that is given by the simulator. So what is the default size of this constant? So since it is decimal, so that is 32-bit size. Okay, whatever it is, whether it is decimal, hexadecimal or octal, the same thing. The default bit size is of 32-bit. Okay, that means what is the meaning of this? Means, for example, if you are giving 5 tick D5, then what happens? It will allocate only 5-bit size. But if you are not giving 5, then it will be allocating 32-bit sizes. Got my point? Yes, so this is about sized and unsized. So as I already told you, these are values. Okay, like any value, you can give any type of value you like. Okay, for example, whenever you see some programs or whenever you see some outputs randomly, generally you will be having these things like X and Z. Okay, what does this mean? So basically in Verilog, it is a four valued system. Four valued system means it is having four values. One is 0, 1, X and Z. Okay, 0 is nothing but it is of 0 and 1, you know, like low and high. Okay, whenever the value is unknown, it is considered as X, and whenever the value is high, okay, then it is considered as Z. Okay, basically these are the four values that you will be mostly using in any language. Mostly in Verilog you will be using these four things. Okay, for example, if you see here 12 tick H1 to X. So if you see here, this is of 12-bit. Okay, this is of 12-bit, and which is hexadecimal number, 12-bit hexadecimal number. Okay, you got it. Now 1 to X is a 12-bit size. Now what happens? So 1 is nothing but 0001, 2 nothing but 0010, and then X is nothing but there is no value, like unknown value. So the remaining four spaces are given for X. Okay, for example, if you see here 2 tick O hex 14. Okay, here this is the wrong one. Why? Because you have said that 14. So, and but you have taken the size as 2. Okay, the size is 2 and the value is 14. X14, not even 414, that is X14. So what happens basically, since it is the size is of only 2, then only two zeros, that means the zeros will be written, like some default value will be placed here, or else in some simulators, based on the simulator, some simulators will throw you error that your size is not correct, or some simulators will give you the default values or zero values. Okay, this is not the correct value. That's what I tell you, it will dump some whatever value it likes into your particular variable. Okay, so 4 tick b 0 1 x 0, since this is of 4 size, so 0 1 x 0 is stored as 0 1 x 0, 0x. Okay, so this is about sized versus unsized, and x and z values in constants. How are you going to use x and z values in constants? And then coming to negative numbers, how are you going to represent negative numbers in the Verilog? So basically, I think you already know, whenever it comes to negative in any digital electronics, negative number is nothing but 2's complement of that particular number. Similarly, in Verilog also, whenever you want to represent a negative number, it is taken as 2's complement of that particular number. See, if you see here, 8 minus 8 tick d3, what does this mean actually is, the size is of 8-bit tick, and what you want to use, it is minus 3, you want to represent minus 3. Okay, but you shouldn't give it in this way. Even though you want to represent minus 3, the symbol should be in the starting itself, not in between. Okay, not in the middle. Did you get my point? So that means you want to represent minus 3. So what happens? It is of 8-bit size and it is decimal format, and then minus 3, nothing but 3's complement, 2's complement of 3 will be stored in that particular variable. Got my point? So this is how the negative numbers are represented. And then so basically in Verilog, generally when you want to assign like negative numbers, okay, again these constants are like variables, in whichever variable you want to assign. For example, a, okay, a equal to 3, fine, it is a positive number, everything is fine. For example, you want to assign a equal to minus 3. Okay, now what happens, that a should be capable to store your minus 3. That means that a should have the designation in order to store your negative number. How can you do that? Generally, we will be using signed and unsigned categories. So unsigned category means it can store only positive values. Okay, see here, when it comes to unsigned, okay, it can store only positive numbers, whereas when it comes to signed category, signed means it can store both positive numbers as well as negative numbers. So whenever you want to assign some a equal to minus 3, then that a should be first signed variable. Okay, whenever the a is signed variable only, then only you can store value of a equal to minus 3 in that particular a. Okay, so so how will you do, like how you make this a as signed? Simple. See, so whenever you want to store some variable, okay, store some negative variable, then what you should do, you should first make that variable. So if you see here, rate signed s. Okay, so now this s can store minus, see, for example, 7 down to 0 means this is of 8-bit. Okay, we'll be seeing this later. What is this? This is the vector representation. Okay, so 7 down to 0 means 8-bit. Okay, so now when it is 8-bit and it is a signed character, so it can store all the values from minus 128 to 127 in the number scale. Okay, for example, if this is the number scale you consider, and it is of 8-bit, so it will be storing from minus 128 to 0, minus 1 0 to 127, all the bits. Okay, when it is a signed. Okay, but when this is unsigned thing, when the same thing is unsigned, like when the same s is unsigned, then what happens? It can only store the positive values from 0 to 256. Okay, nothing but 0 to 255. Got my point? Okay, so basically whenever you want to store a negative number, then you should make that variable to be capable of storing that negative number. How will you make that variable capable? By assigning a signed value to that particular thing, by assigning a signed keyword. Okay, so this is basically about signed and unsigned, and these are some of the examples of signed and unsigned numbers. Okay, like sized constants, unsized constants, x or z, real or constant numbers, like negative constant numbers and all. Okay, so next coming to strings. How are you going to represent a string? String is nothing but, whenever it's nothing but ASCII, group of ASCII characters, like group of textual matter, okay, which is written within the double quotes. Whenever you want to represent something, like whenever, like heading, like before writing the logic, whenever you want to write something on your output, okay, whenever you want to display something, so that displaying, generally we will be using strings. In Verilog, whatever you want to write, you should be writing it in the double quotes by using the strings. Okay, so here see, string equal to hello world. Okay, so if you see here, as I already told you in the lexical token starting, white space is not considered in string. What does that mean? Means here this white space is also considered as a character in Verilog. Okay, so this is about strings. So this is all. I mean, there are remaining lexical tokens also. I'll be doing that part 2 of lexical tokens. Okay.